Welcome. Today we are going to be doing law of sines. Now, law of sines is all about proportions, setting up proportions. Sine of A, angle A, capital letters for angles, lowercase letters for sides. Sine of A over side A equals sine of B over side B equals sine of C over side C. Two fractions equal to each other. Any two of these three are acceptable to have equal to each other. All right, so if this is our problem, now don't assume anything from the graph. Don't assume longer sides, shorter sides, bigger angles, smaller angles, okay? This is just a quick sketch. Most of them I use like an equilateral triangle. So measure of angle C, we're told that that is 75 degrees. We're told measure of angle B is 59 degrees. Obviously, that's not a 75-degree angle. That's an obtuse angle. Ignore that idea. Side B is 24 in length, whatever unit that is representing. Doesn't matter. We're going to use the same unit throughout, so it wouldn't really matter. All right. So, given that information, let me just move my mouse so that it's not showing up there. All right, that's better. Given that information, we are talking about a proportion, and I'm going to use B because I have side B and angle B. I have been given that. I have angle C, so I can find side C. Given B and B, sine of angle B, 59 degrees, over side B, 24, equals sine of angle C, 75 degrees, over side C, the unknown. So the first thing I have to do in this process is I have to use my calculator or a table and find sine of 59 degrees, 0.8572, round to 4 decimal places, over 24 equals sine of 75 degrees, 0.9659 over C. I will then proceed to cross multiply. I always multiply diagonally down. Doesn't really matter, but it has to be one direction. So let's see, 0.9659 times 24, 23.1816 equals 0.8572C. Now, when I do this, one of the big things I want to pay attention to is I don't want to round any decimals other than for sine. I'm going to round the value of a sine to 4 decimals, and I'm going to round the final answers, sides 2 places, only the final answer, side 2 places, angles 1 place. I have to divide both sides by 0.8572. So 23.1816 divided by 0.8572. The final answer rounded to 2 places, 27.04. So I'm going to come back up to the top, 27.04. Let's get rid of that, so it's not in the way. All right. Now, I have angle A missing and side A missing. To be able to find all the missing parts, I need to, well, think about it. What do you know about a triangle's angles? Well, they add up to 180. So if I have 59 and 75, 59 plus 75 is 134. So the remaining angle must be what adds up to 134 to get to 180, or 180 minus 134, that's going to be your remaining angle, 46 degrees. So angle A, given that, is 46 degrees. Now I can use the proportion and solve side A. Now when I do this, I suggest using the side that you're given and the angle that you're given, not a side that you found if you can help it. Because the side you found has been rounded. There was rounding when you made these, there's rounding when you got to the actual side itself. So the less rounding involved in your problem, the more accurate it's going to be. So if I'm going to solve again for side A, I'm going to use angle B, 59 degrees, and side B, 24. Angle A was 46 degrees, and side A is the unknown. So I'm going to I'm going to first find these values. Now I already have sine of 59 is 0.8572. And 46 degrees, the sine is 0.7193. Then I cross multiply, let's see, 0.0193 times 24, 17.2632, 0.8572a, divide by 0.8572, and A ends up equaling 20.14. Wow, those are close. 20.14. 4. So they're all in the 20s for sides. I'll bring this back down so you can see it again. There's solving for side A. Solving for angle A, solving for side C. And that was the process of solving the triangle. Now you can do that in certain circumstances for law of sines. For other circumstances, you need law of cosines, which we'll learn later. Here's another example. See if you can set up, given the information, and solve for x. All right, here we go. Sine of 70 over side 20, because those two are connected. Sine of x over 21. Now, if you tried this on your own, you may have gotten to a certain point and gone, all right, now where do I go? I first find sine of 70. Make sure you're in degrees. Cross multiply. 20 sine x equals 0.9397 times 21, 19.7337. Now I'm going to divide both sides by 20 to get sine of x by itself. Now I'm not going to round that to 4 decimal places. I'm just going to leave it, and there it is on my calculator. Well, you can't see it on my calculator very well. There it is on my calculator. And I'm going to use a button called inverse sine. The symbol is, it looks like sine, but it's got a -1. It looks like a -1 power. It's not a -1 power, it means inverse. Now, usually that is in a secondary mode of sine. So the sine button, just above it, is usually the inverse sine. I have to hit shift and then sine, because that's above it, and it gives me the value of, it's the inverse operation of sine. So x equals 80.639606, 1 decimal place for angles. 80.6 is my answer for the angle that we started with. All right, so back up here, that angle is 80.6. Here's another example for you to give a try to. Just find side C. Go ahead, and then I'll do it myself. All right, so it doesn't matter which one you call A, B, and C. Let's label them A, B, C in this case. Angle A is 35 degrees. Angle B is 65 degrees. Notice it's just an equilateral triangle. We don't know angle C. We know side A is 60, and we're trying to find side C. Well, I have one proportion here, right? I need another proportion for C. Well, right now I don't have enough information, but to find that remaining side, 180 minus the sum of the two angles, 35 plus 65, that's going to give me angle C. All right, so 35 and 65, add those together is 100, and so that's 80. Measure of angle C. I should have an M for measure of. All right. So angle C is 80 degrees. Now I can set up my proportion. Sine of 35 over 60 equals sine of 80 over unknown. Now I could put C or I could put X, whatever you'd like. All right, 35 sine, 0.5736 rounded. Sine of 80, 0.9848. So cross multiply, 60 times 0.9848, 59.088, 0.5736C, divide by 0.5736, C is going to be 103.01. So that's the length of side C, 103.01, and all done. By the way, one thing you should note in general, the length of the longest side is always across from, opposite, the biggest angle. The smallest side and the smallest angle. So 103 is is across from the biggest angle, and 60 is across from the smallest angle, so this must be somewhere between the two. Just a little information there. All right, give this one a try. Find x. Sine of 29 over 35 equals sine of unknown angle t over 36. Since they're over very close values, they should be fairly close. Let's see, sine of 29. 0.4848. Cross multiply, 35 sine of x equals 36 times 0.4848, 17.4528. I then divide by 35. Sine of x equals 0.498651428. Now I only write that out in normal work. I'm not necessarily going to spend the time to write that all out, but I'm going to hit inverse sine, and x is 29.9. Wow, that's pretty darn close to 29, like we said. Degrees, by the way. So 29.9 is the answer. All right. Now, sine is interesting. Let me go to Desmos here. And in Desmos, one of the things you're going to notice is that the highest value that y equals sine of x will give you is +1, and the lowest value is -1. And it oscillates, you can see, from -1 to +1 as it goes along. Okay, so since it doesn't go below -1 or above +1 anywhere on its graph, then the value of sine is only between those two. Now, that's going to come up a little later. I meant to bring that up later. Sine here, this is what I meant to bring up, but you'll see that other part come up in the next slide. All students take calculus, right? All trig functions are positive in the first quadrant. Sine is positive in the second. So that's positive. So there's two possible answers here. The first, 0.8192 inverse sine, theta, is possible to be, this is approximate, 55 degrees. It's 0.00 in this one. 55 degrees is somewhere around there. So that is one possibility for theta. But the other possibility is theta could be over here, 55 degrees from that, right? But how far is that starting at our normal starting point where we measure angles? Let's see. Well, 180 minus 55 what's that, 125? I could do that in my head, yes. So this angle is 125 degrees. And it turns out if you do the sine of 125 degrees, it comes out to this same value. So the other answer is 125 degrees. So you don't have to write this out. I just did that for demonstration purposes. But if you want to find the two values of sine, two angles that sine theta can be for sine of this, the first angle is just inverse sine, and that's this one. And then you just do 180 minus that value, and it gives you this value. Those are going to be the two values, the supplementary angles. They have to be supplementary, add up to 180. These two are the two possible values that sine could be. In this one, we're going to find something interesting happen here. Sine of, let's see, we're trying to find angle A. Sine of 25 over 5, not 20 yet, over 5 equals sine of angle A over side A. Sine of 25 degrees, let's see. 25 sine, 0.4226 over 5. Sine of A over 20. Okay, cross multiply. 0.4226. Yeah, 0.4226 times 20. 5 sine A equals 8.452. Great so far. Divide by 5 to get sine by itself. Sine of A, divided by 5, 1.6904. Now a minute ago, we just said that sine by itself, without a multiplier or addition or subtraction with the expression, sine of an angle can't be bigger than 1 or smaller than -1. It has to be either equal or between. This is bigger than 1. If you try to do inverse sine with that, it's going to give you an error. So this is not possible. Now the other thing that you need to know about triangles is that any two sides, the sum of any two sides of a triangle have to be bigger, the answer has to be bigger than the remaining side. And the other way you can think of it is the smallest two sides have to add up to something bigger than the longest. Here's why. Imagine you have just a line, that's the side, right? If I have one side here, and I have another side here, are these three sides going to make a triangle? No way. This one's going to fall, and this one's going to fall, and you can see they're going to fall short. That's why they have to be longer than the longest side when you add them together. So that information, along with the fact that the biggest side across from the biggest angle, smallest side across from the smallest angle, will help you determine when you're working with triangles which of the two angles it should be if you had to pick. Remember the 55 and the 125? Which of them it should be. All right, I believe that's the end of our lesson, and the homework will be in Google Classroom. Have a great day.